You think the sun just rises and sets? Think again. For thousands of years, ancient astronomers noticed something much deeper, a secret journey that defies simple daily rotation. Each day, the sun advances exactly 1 degree eastward, completing a full circle in the cosmos in a year. This annual highway among the stars is known as the Ecliptic. But there's a crucial twist. This path is tilted by 23.5 degrees, and it's the exact reason we have seasons. More astonishingly, every wandering star, the moon, and all the planets follow this same narrow highway, the Zodiac. In the 4th episode of the Astronomy for Beginners series, we will examine how the sun, moon, and other planets move along this ecliptic path. If you're ready, let's begin. Let's first focus on the movement of the sun. It is observed that the sun rises in the east every morning and sets in the west every evening. This phenomenon is a result of Earth's rotation on its own axis. However, ancient astronomers, through careful observation of the sky, noted that the sun's apparent motion is not solely due to Earth's daily rotation, but also involves a slower and more complex movement with respect to the stars. In this context, the sun's position in the sky is not fixed and does not move together with the stars. Because the Earth rotates on its axis while also orbiting the sun, we observe the sun's shifting position relative to the background stars throughout the year. The sun advances about 1 degree eastward on the celestial sphere each day. As a result of this motion, a full circle is completed over the course of a year. In astronomy, this annual path that the sun traces among the stars is called the ecliptic. This movement has an important effect on our daily lives. Compared to the stars, the sun rises about 4 minutes later each day. This is because by the time Earth completes one rotation on its axis, the sun has shifted roughly 1 degree in position. Consequently, for Earth to observe the sun in the same position again, it needs to rotate about 4 minutes longer. The most important point in this section is that the path of the ecliptic does not proceed in the same direction as the celestial equator. The ecliptic is positioned at an angle tilted 23.5 degrees to the equator. The reason for this is that Earth does not stand upright in space. Its axis is tilted at a certain angle. This 23.5 degree axial tilt directly affects the sun's annual movement across the sky and the formation of the seasons. In the later episode of our Astronomy for Beginners series, we'll examine in more detail the role of this axial tilt in the creation of the seasons. Now that we understand the sun's special path called the ecliptic, let's take a look at other interesting figures in the sky. When ancient Egyptians, Mesopotamians, and Greeks studied the heavens, they encountered 2 different types of celestial bodies. The first were fixed stars, whose positions never changed and always kept the same constellation patterns. The second type stood out as bright points that freely wandered among these fixed patterns, defying the rules. The ancient Greeks called these celestial bodies planets, meaning wanderer. The modern term planet also comes from this concept of wandering. At that time, since telescopes had not yet been invented, this category included 7 celestial bodies: the sun, the moon, and the 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. Because the sun and moon were not considered fixed stars, they were also thought of as planets until the development of the sun-centered, heliocentric model of the universe. These 7 celestial bodies were regarded as sacred in ancient societies and played a significant role in the measurement of time. The answer to why a week has 7 days lies in the celestial bodies. The 7 days of the week were dedicated to the 7 wandering celestial bodies known in ancient times. The civilization that first developed the concept of a 7-day week was ancient Babylon. In many Western languages, the names of the days still reflect these celestial bodies. For example, in English, Sunday means Sunday, Monday means Moon Day, and Saturday means Saturn Day. Therefore, we can still observe the influence of ancient astronomy in our modern calendars. At the same time, these 7 planets were considered sacred in many beliefs, were named after gods, and served as the basis for cosmological arguments put forth by religions. For instance, it is known that the names of the planets come from ancient Roman gods, which in turn were derived from ancient Greek and Babylonian sources. Among these celestial bodies, the moon stands out for its movement, and, as Earth's closest neighbor, it can be observed making the fastest apparent motion in the sky. The moon completes a full circuit across the sky in about 1 month. In fact, the origin of the term month comes from this motion. Each day, the moon moves about 24 times its own diameter, approximately 12 degrees to the east, so it rises about 50 minutes later each subsequent day. The movements of the other planets in the sky, however, are much more complex due to their own orbital dynamics and the fact that Earth itself is also moving as our observation platform. As a result of this combination, planets can sometimes appear to stop or even move backward. This apparent motion was one of the main problems astronomers tried to solve for a long time. The complex motions of the planets will be discussed in detail in later episodes of our series. At this point, it is important to mention a significant geometric principle related to the movement of celestial bodies. One might think that the sun, moon, and planets move randomly and irregularly across the sky. However, in practice, all these celestial bodies can be observed along a narrow band in the sky, aligned in a specific order. So, what is the reason for this? The structure of our solar system originates from its formation. Since the solar system initially formed from a massive cloud of gas and dust, the planets and the moon all orbit the sun in almost the same plane. You can imagine this like a large sheet of paper spread out on a flat table, with everything moving along that surface. Nothing veers upward or downward. So, even though the sky is three-dimensional, the movement of celestial bodies mostly occurs in a two-dimensional plane. When observed from Earth, this broad plane is perceived in the sky as a band or belt. This belt is centered on the ecliptic line, is about 18 degrees wide, and is known as the Zodiac. The sun, moon, and all the planets are continually located within this zodiac belt. The term zodiac is derived from zoo and literally means circle of animals or collection of animals. The reason for this is that the star patterns behind this belt were in ancient times often likened to animals such as Leo, the lion, Cancer, the crab, Pisces, the fish, or Scorpius, the scorpion. The constellations within the zodiac belt are also called zodiac constellations, and the signs of astrology are in fact these zodiac constellations. We have discussed the planets and the paths they follow across the sky, but it is also necessary to mention the background stars. In an area far from city lights and in complete darkness, about 3,000 stars can be observed with the naked eye. Throughout history, various civilizations have tried to understand the order of celestial objects by grouping these stars. This practice is similar to examining patterns formed by connecting dots in the sky. In many cultures, such as the Chinese, Egyptian, and Greek civilizations, different mythological figures and symbols were developed relating to these groups of stars. Many of us are familiar with star patterns like the Great Bear or Orion's Belt. However, as scientific progress advanced, simply naming the brightest stars was no longer enough. With the development of telescope technology, millions of faint stars also became observable. Today, in scientific terms, a constellation does not refer to a specific arrangement or pattern of stars, but rather to each of the 88 official regions of the celestial sphere. You can compare this situation to how a country is divided into states. For example, just as the borders of the state of California are clearly defined on a map, Orion is also a box-shaped region in the sky with clearly drawn boundaries. All celestial objects located within this area, even the faintest galaxy, are considered part of the Orion constellation. Additionally, the shapes that were historically given to certain groups of stars, such as the Dipper form within the Great Bear constellation, are now called asterisms. We will cover more detailed information about constellations and the coordinates of celestial objects in future episodes of this series. In conclusion, the ecliptic, which describes the sun's annual movement, the zodiac, which is the mandatory path followed by the planets, and the 88 modern constellations that divide the sky into sections, are fundamental elements for studying and understanding the universe more easily. However, we have only scratched the surface of our cosmic map. If you enjoyed tracing the paths of the sun and the planets, don't forget to like this video and subscribe to our channel. You can watch the other videos in the Astronomy for Beginners series via the links in the description below or at the end screen. See you in the next video.